All right, welcome to Translations Part 1. What a translation is, it's kind of a push. What we want to do is we want to take some kind of a graph of some kind of function, and we want to push it to the right or the left, or maybe up or down. So I'm going to start off with showing you how these pushes work. So let's take a very nice, simple little function like the square root of x. Now we know, and I'll do a very quick version here, we kind of know what this graph looks like. It's 0, 0, 1, 1, and then there was 4, and that's up 2 units. Okay, so we've got this guy over here. There's our original function. And what we might want to do is, I don't know, let's move this thing 3 units to the right. Okay, I'm going to show you how we do that. Now, first of all, if we're moving this thing 3 to the right, okay, right and left is a change on the x location. Okay, right and left stuff has to do with x's. It's up and down that has to do with the y. So this has nothing to do with the y in our first little example, just the x. Okay, so here's how you have to do this change. You locate in the function, so here's our function, it's the square root of, you locate that x, and then you tack on either a plus 3 or a minus 3. Now I'm going to put in minus 3 because I know that's the answer, but I'm going to convince you that that's doing the right thing. And I'm going to convince you of that with a little table of values. We're just going to plug in enough points to see if our graph really is this graph pushed 3 units to the right. So I might like to try to plug in 0, but I'd quickly see, 0 minus 3, I can't square root a negative number. And that would be true with 1 and 2 as well. In fact, it's not until I plug in 3 that I can actually get a value for this. So 3 minus 3 is 0, and when I square root 0, I get 0. Oh, isn't that interesting? 1, 2, 3, 0. So it's almost as if the point 0, 0 got bumped over to here. If that is true, then if I plug in the point with 4, then it should be 1 over and up 1. Let's see. 4 minus 3 is 1, and the square root of 1 is 1. So yeah. There's 4 and it's up 1. So there's my graph, more or less. And it does look, in fact, like it has been moved 3 to the right. So to make a long story short, say I wanted to move, 5 to the left. Okay. All I got to do is locate the x, because that has to do with left and right. So I locate the x, and I tack a 5 on. Only this time I want to move it 5 to the left, so it's actually going to be plus 5. Okay. Now here's a way you can kind of remember. Some students just like to think if you're moving to the left, which is the negative direction, then you do the opposite sign. Another way to think of it is, I would like to make this turn to 0. It's kind of like when we located vertices in grade 11. So it's kind of like looking at this and saying, well, the x-coordinate of this would be negative 5. In order to turn this into 0, I'd want to plug in negative 5. And that's probably a pretty good way to think about it. Now, that's how the left and right stuff works. So, let's say you want to go 7 to the right. Okay, no problem. There's the y, no changes there. And there's the x, and I want to make a 7. And this time I want to move it over to the right. So I'm going to make this minus 7, because I want to move it to positive 7. And positive 7, when I replace the x with positive 7, does make this equal 0. Okay, that's kind of how I check my work. Now, what about moving things up and down? Well, let's say you had the same function, and you wanted to move it, say, 3 up. Okay, first things are, are that has to do with the y stuff. Up and down is y stuff. So leave your x stuff alone. Leave that alone. Find your y's, and you're going to tack a 3 on. And in the same way that it worked with x, we want to move this up, which is kind of a positive direction. So I know this is actually going to be y minus 3. And again, it's because if I plugged in positive 3, then this would equal 0. Okay, so that would be my function. Now, the way I've written it, where I've made the change right into the function, right next to the y, this is actually what we call implicit form, or implicit notation. I find it easier because it's very consistent. The way you treat x is the way you treat your y. There is another way to write these functions, however, and that is to get the y by itself. In other words, I could have taken the minus 3, I could have added it to the other side. So I could do this. Okay. The reason they sometimes write it this way is because then it works with function notation. You could say, oh, this is the function g of x, or something like that. Okay. This, by the way, is called explicit notation. But I find that explicit notation it's more awkward because you're having to kind of think backwards for the y stuff than what you did with the x stuff. So I much prefer, if we can, to stick with implicit. Okay, I think I'm going to stop there. I'm going to come back with some other examples, maybe with some other functions. So we'll catch you in a while.